Right, let's continue. A lighthouse L is on an island 4 miles away from the closest point P and the beach. If the lighthouse rotates clockwise at a constant rate of 10 revolutions per minute, how fast does the beam of light move across the beach 2 miles away from the closest point on the beach? Very interesting. Very interesting. Okay, that's theta. And where should I have it start? I guess I could just have it start here, just arbitrarily. T equals 0. And we'll call that theta, which, by the way, makes that theta too. Okay. So we'll call this distance here x. And we're looking for how fast does the beam of light move across the beach. So we want dx dt, which will be dx d theta dt. And we know that d theta dt, it's 10 revolutions per minute. So that'll be a 10. And then the x d theta. So we need a formula that relates x and theta now. What would I say? I could use the 4. I could say tan theta equals 4 over x. So theta is tan inverse 4 over x. So if we put that in here, that would be minus 4 over x squared, 1 over 1 plus 16 over x squared. And we have to sub in x is 2. So let's grab the calculator here. Minus 4 over 2 squared plus 1 over 1 plus 16 over 2 squared. Times 10. So that's minus 8 miles per minute. So the speed is 8 miles a minute. Let's check the answer. Uh, 100 pi. A 100 pi a minute. Really? 100 pi a minute? 300 miles per hour? That doesn't seem right, does it? That really doesn't seem right at all. I wonder if I made a mistake. The x dt, the x dt to... Oh, I forgot to change this. That's what yeah, sorry, that's a divide there. I forgot to do my usual flip. So, because that's theta, not x. Yeah. Yeah. Although if I wanted to make my life easier, actually, what I could say is note the theta dt equals 10, and also that tan theta equals 4 over x, so x equals 4 over tan theta, so that means dx d theta is 4 over tan squared theta, and then, oh, what's the derivative of tan? It's 1 over cos squared, isn't it? So sine squared over cos squared, 4 over sine squared theta. So this would be 10, so 40 over sine squared theta. And sine theta in this picture will be 4 over root oh no, it's not 10. I have to correct myself. 4 over 20. So yeah, my mistake here. 10 revolutions per minute. I need to use a little bit of physics knowledge here. The omega is 2 pi over t, or t is 1 over f. That's 2 pi f. That's 2 pi and times 10 if we're using minutes instead of seconds. So 20 pi. So that should have been 20 pi. So that should have been 80 pi. So then that will equal 80 pi over sine squared, which is 16 over 20. Yeah, I'm honestly 100 pi miles per minute. I'm actually shocked by how fast that is, but that corresponds with the answer at the back. So there you go. Surprise, surprise. 40. Using the same setup as the previous problem, determine at what rate the beam of light moves across the beach 1 mile away from the closest point. Oh, use the same setup as the previous rate at which the beam of light moves across the beach 1 mile away. So if that's just a 1, it would mean the speed would be 100 pi divided by 4, because it's smaller. Well, you know what? I'll just go back to this formula. It wouldn't be 80 pi, it'd be 20 pi. And the sine squared would be different, because it'd be 1 and 2. So that is root 5. So that's 1 over root 5, or 1 over 5. Oh, really? The same answer? 100 pi miles a minute? Oh, that's funny. So that 4, did that come into the calculation here, or am I mistaken? That 80 is from the 20. That doesn't contain the 4. And the 10. No, actually, no, it's still 80 pi. So that's 400. Or 4,000. 400, sorry, 400. Yeah, okay, that makes sense. That makes sense. It's 4 times faster, because it's closer. If you take it to the extreme, if it was further away, it wouldn't appear to be moving as much. Yeah. The only thing that's changed in my formula Oh, no, no, no. I should highlight where I've used the 4. The 4, dx d theta dx, the theta dt is still 20 pi. That doesn't change. But the tan theta, that 4 now has become a 1. So that's 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 not 80 anymore. That's not 80 anymore. And likewise, that's not 16 over 20. Yeah, okay, no, I think I was right the first time. So that's 20 and 1 over 5. Yeah, 400. Yeah, yeah. 4 times smaller on the top, and also the sine squared changes on the bottom to 1 over root 5. Yeah. Okay. Okay, I think that's right. 41. Okay, so it's a different question. I can clear this off. Right. You're walking to a bus stop at right angle corner. You're riding the bus stop at right angle corner. You move north at a rate of 2 meters per second and are 20 meters south of the intersection. So here you are here. You're moving north at 2 meters per second and you're 20 meters away. The bus travels west at a rate of 10. Bus travels west at a rate of 10 meters per second away from the intersection. You've missed the bus. What is the rate at which the angle between you and the bus is changing when you are 20 meters south of the intersection and the bus is 10 meters west? There's the bus, 10 meters west, heading at a rate of 10 meters per second. And they want to know what is the rate at which the angle between you and the bus is changing. Now, which angle are they referring to exactly? This angle here, perhaps? I'm going to go with that. Okay, so tan theta would equal the numerator. Its length would be 10 plus 10t over, and the denominator, which would be 20 minus 2t. So, what's the best way I want to do this? I'll just go chain rule. Theta is tan inverse 5 plus 5t over 10 minus t. So d theta dt, that would be the quotient rule. 10 minus t squared, 10 minus t times 5, minus, so plus 5 plus 5t, times, and then 1 over 1 plus 5 plus 5t over 10 minus t. But the way I've drawn the picture is that the angle we're interested in is when t is 0. So if you put in t is 0, that's 0, that's 5, that's 10 plus 5 is 15 over 100 times 1 over 1 plus 5 over 10 squared. So let's see what that is. Um, 3 over 25 radians per second. I don't know if that's right. 41. 11 over 25. Oh, rats. Oh, unless they were talking about this angle. Possibly. Let's just double check I haven't made a mistake. The bottom squared, the bottom times root of the top, minus the top times the root of the bottom. T is 0. I have made a mistake because 10 times 5 is 50. 50 plus 5 is 55. And then 10 minus 0, 10 squared is 100. Then 1 over 1 plus that, t is 0, but it's a half squared. A half squared, I've made another, no, I don't think I made a mistake, there's a half squared, okay. 55. 11 over 25 then. Yeah. Oh, a little bit tired today, a couple of silly mistakes, but we got the answer that matched on the back. I'm just a bit tired, so I'm not feeling super confident about that one. But the fact that the answer is 4 times greater kind of seems right. It's not a good reason, but anyways, let's leave it there. 39 to 41.